Jupyter Notebook environment last time for the last module. So want to make sure people have those instructions. So I'm going to share those again. Screen one, share. Okay, so again, if you navigate to nanohub.org and you hit login, and it'll be on the top right if you're in kind of the full screen. The colors will be a little different, but you're basically looking for login. You'll get a screen like this where you can either create a new account or you can log into an existing account. If you navigate through here, so your best bet is probably going to be your Google or your affiliated institution. Once you navigate through here and you fill in, you give your biographical information if it's your first time, you're going to be able to sign in using your preferred method. And again, I typically use the Google login, but you can have a nanohub account or your affiliate institution. And then you're going to want to go to nanohub.org/tool/Jupyter70. The easiest thing is to type that into your browser, nanohub.org/tool/Jupyter70. And then when you'll get a screen like this, hit that collect button so it'll show, so Jupyter Notebook will show up on your home screen from now on, and then hit launch tool. Once you've hit that launch tool button, you'll get this window, and then you can select new, and you can select any of the Python 3.7s. So you can just use the top one, or 3.8, doesn't really matter, any of the Python 3s, and launch a new notebook. And your new notebook will have empty cells like this. Okay, at this point, I'm going to, please message in Slack if you're having trouble with those instructions. But at this point, I want to continue with the second module. So far, we've talked about certain data types, and we've introduced the concept of conditionals and a lot of control flow for how to get Python to do different things. But one of the most important things that in Python for CompuCell 3D is the objects that we're going to use. You're going to be representing cells and tissues and morphogens and all kinds of different things as objects in Python. And so we want to work a little bit on how those objects are collected and how they're used. So we'll start with the simplest of them. So which are sequence. So these are all sequence types. And we'll start with the simplest of them, which are one-dimensional collections of objects. The most common of these are strings, lists, and tuples. And you can use the following syntax to make them. So let me launch an empty notebook. So to make a new string, you just, as we mentioned before last time, you just have to have 2 quotation marks, and then whatever's inside is a string. And then you can assign that to a variable so that you can store that forever. Similarly, with a list, you can do just the simplest way is to do a bracket. You can have a collection of numbers in a list. You can have collections of other objects too. Tuple 1. So we'll just do tup1 equals. And then we're going to teach you a set of, now we're going to go over a set of operations that you can use to work on those simple 1D collections, and then we'll work on more sophisticated ones that will allow us to keep track of more sophisticated biological elements. So the first thing is string, which we've already done before. As we've mentioned before, you can evaluate strings just as we can evaluate integers and floats, but think of them as a sequence of case-sensitive characters. So this string 1, we can evaluate it in many ways. So we can throw a built-in function called len around it, and that will tell us the length of that string, 30. You can do the length of a different string, which we'll call string2 equals so you can imagine how a string like that could have biological relevance. And you can again do length of string2. So you can collect data in that way. And then you may need to isolate specific elements of that string and to access them. And so this is called slicing. That's accessing individual elements of them one at a time. So just like with range, is slicing in strings uses the start, stop, step method. The default step is 1, so it's often not included. If you give 2 numbers, it'll give you the start and the stop. Just like with range, the stop is exclusive. The start is inclusive, but the stop is exclusive. And I'll demonstrate what that means in just a second. And then you can also omit numbers. And the other thing to know is that Python is 0 index, meaning it starts with zeros. So let's create a very simple string. A, B, C, D, E, F, G, H, I. So that is a very simple string. And I use that because you have some intuition about where what the position of those letters are. So if we go and we do S 3 to 6, that's going to isolate characters 3, 4, and 5, because it's not going to include character 6. So that's D, E, F. You might be a little bit surprised, but remember, you start with index 0. So A is 0, B is 1, C is 2, and 3 is D. So D, E, F is 3, 4, and 5. And then the 6th character is not included when you do the strings. And again, this has the implicit. This is the same as 361 because that one step is the default. If you were to use a different step, a step of 2, so if you go to 3, if you go from 3 to 6 by 2s, it's going to go 3, skip 4, go to 5, and then end there. So you'll get just 3 and 5, which will just get D and F. Oops. Okay. So you just get D and F. And then when you don't specify the start or the stop, it assumes that the beginning or the end of that string is the start and this is the start and stop. So if you go S, if you do this, S with no beginning character specified and the ending character of 3, it's going to give you 0, 1, and 2. It's going to give you A, B, and C because it assumes the default is the starting character. Similarly, if you do S and then you start at 3, remember S of 3 is D, 0, 1, 2, 3, and then you don't specify an ending character, it's going to go to the end of the string, D, E, F, G, H, I. All of these are the same if you don't specify the one-step character, because once again, that's a default of 1. So you could have 2 colons here. And it's the same. It doesn't change it because that last input is the step size, and the step size has a default of 1. There's other, The other thing to be aware of is the negative step size. So you can do S from 6 to 1 by -1. So that's going to go backwards through the string. GFEDC. So yeah, so those are the characters that so that's string slicing. You can also access an individual character just by providing the index position. So once again, if we bring up S here, we can access each individual character through its specific index position. S of 0 is A, S of 1 is B, S of 3 is D, and then you can also index from the end. So -1 is going to be I, -2 is going to be H, -3 is going to be G. And it's always using these square brackets for index positions and for slicing. If you ask for a character that's outside of this, you'll get a specific error. So there's 9 characters there. So if you ask for 14, you'll get index error. String index is out of range. So it's out of the range of the number of characters that's there. So let's give this a shot. Given a string S of length at most 200 letters and 4 integers, A, B, and C, and D, the slice of this string from indices A through B and C through D inclusively. In other words, we should include elements SB and SD. So let's take a look at how we would do that. I'm just going to do that one together, and then we'll do the rest of them separately. So I'm just going to copy that in. S2 equals, okay. Humpty Dumpty sat on a wall, Humpty Dumpty had a great fall, and so on, okay? Let's say that A is equal to, because we want 4 integers, right? A is equal to 22, B is equal to 27. Let's say C is equal to 6. And D is equal to 11. Oops. So and then if we slice those together inclusively from A to B, inclusively, so it's S2 from A to B, that would be, the B wouldn't be included. So if we want to include the B, we have to do that. And then let's connect it to a slice from C to D inclusively. So C to D was 6 to 11. That was these spaces. And then 22 to 27 was these characters that I'm highlighting here. The point of this was to show that you can use variables in these index positions to represent numbers. And Yeah, variables in index positions to represent the numbers. So these can take place in that, and that can help with different operations that you need to do. Okay, you can reverse a string. So write a program that starts with a word and reverses it. So if we take the word welcome, let's say S3 is equal to welcome. We can reverse this by taking the last character and the last character and so forth. So we can set up a for loop to iterate through each of these. We can set up a while loop. So there's multiple options here, but let's just do the simplest one. So when you're iterating through one of these strings, you can do it by index position. So for X in range, so len, so we're nesting these two functions together, S3. So just to show you what that does, let's just print X. Range length X3. So that there are 7 characters in S3. So the length of S3 is 7. Throwing a print on there because only the last print statements will get shown. So there are 7 characters. There's the length of 7. The length of S3 is 7. So if we do range 7, we get 0, 1, 2, 3, 4, 5, 6, as we've done before. Those can be used to slice. So then we can, instead of printing X, we can print S3X. And that accesses each individual letter. What this lets us do, if we want to reverse it, is we can store each of those individual characters. We can access those characters in the reverse order. So if we have 0 through 6, we can do seven, 6, 5, 4, 3, 2, 1. So then we can use that to access the individual, we can use that to access the characters of S3 by index position. Now, if we do this, we're going to get an error on the first one because it's going to be off by 1. Oops. String index out of error. So why did we get that? So the first value there is 7. And S3 of 7 doesn't exist. So we need to subtract by 1. Then we can throw a print around that, and that'll give us the characters in reversed order. You can also do that by using the negative numbers and going through, -1, -2, -3, -4, -5, -6. So there's a number of different ways there's a number of different ways to, okay, so there's a question about cell 22 and cell 23. So in the previous exercise, it just asked us to extract, it asks us to extract elements of that string based on those integers that are given A, B, C, and D. So I just provided C6, C is 6, D is 11, B is 27, A is 22 in order for the output to make sense, in order to extract those specific words. 0, 1, 2, 3, 4, 5, 6 through 11 will give you that. And then 22 through 27 gives you that. So those numbers happen to be provided as part of the sample data set. And then that allows that output. But the point of this was that you can use, you have to use +1s if you want to get to be inclusive, and that you can use variables in place of actual numbers when you're doing this, the slicing. Just as here, we've used a variable that was evaluated from these operations. Okay, I want to move forward and get into the other types of collections, because I think it's more obvious how this works with the other types of collections. So there's more slicing that we can cover. So we've seen range 5 before, right? If we throw that into a list is a, as we talked about at the very beginning, a list is a collection of objects in Python that's represented by these square brackets. Lists can contain numbers, floats, integers, strings, any type of data. They can also contain other lists. So a valid list can be one, two, three, or 1, 2, 3. That's perfectly reasonable. Another valid list could be cell 1, cell 2, and cell 3. In this case, those cells are just strings. They just have text data. They don't have anything associated with them, but you can also put objects in that list. And we'll talk at the very end about how you represent these biological concepts as objects. You can also put nested things inside of lists. So you could have list list 1 and list 2 inside of list 3. So if you wanted to see what list 3 looks like in that case, it's that list and that list. The same slicing that we do with strings occurs with lists. So if we take list 2 and we want to access the second item of that list, we can access it as, sorry, if we so list 2, the second item of it is going to be index 1, right? Because it's 0, 1, 2. The third item in that list is going to be index 2. And you can also, once again, use negative indexing there. The last item in that list is going to be list 1, list -1, sorry. List 2, index -1. And then you can access an item inside of a nested list. So if we want to access cell 2 from list 3, we have to go into the second, what's the second item of this list? The number one, the first indexed item of that list, or the second item of that list, is this list of cells. So to access cell 2 from there, which we've already done, we've already demonstrated that you access cell 2 with index position 1. So list 3, 1 gives us that secondary list, and then the additional position 1 gives us the item from inside that list. So again, you can access nested lists by accessing them one at a time and stepping through them. List. So we've talked about how to build lists through brackets. You can also build them through the keyword list. So you could do list 4 equals so you have to provide a collection into there. So sorry about that. That was a mistake. So list 4 can contain a list that way, but you can also convert. You can convert an object of a different data type into a list using that list keyword. So now if we look at list 5, it's going to convert range 4, which we know is the numbers 0, 1, 2, and 3. It's going to convert them into a list for us. So if we set num, so if we now we can go through these examples. If we set nums as list range 5, we know it's going to be 0, 1, 2, 3, and 4. And if we want to print nums, we can see that it's 0, 1, 2, 3, 4. If we want to slice from a specific part of that, we want to slice the index positions 2 through 4, it's going to also include the number, is going to happen to be the numbers 2 through 4 because it's aligned with that index. And then similarly, just as before, you don't have to specify the start and stop for this. So this will print 2 to the end. And then you can print the beginning to 2, or you can print the whole list with just a single colon by not specifying the start or the stop and using the default values for that. And you can use -1. That's going to start at the beginning, and that's going to continue till the last item of the list exclusively. So it's going to exclude that 4 from the list and just print out 0, 1, 2, and 3. So one thing that we want to point out is that lists are collections that are meant to be changed. These are called mutable. So if we do, yeah, so in a Jupyter notebook, you don't need the command, the print command. If you are remaining, if you want to do 2 of these in the same one, in the same cell, only the last one is going to show up unless you throw on print commands. So when you're in your model, you're going to want to use print commands so that on everything that you want to show up in the display, regardless of whether it's part of regardless of whether it's the last command to be executed there. Okay, so one important difference between lists and strings is that lists are mutable. They can be adjusted. So if we do nums 2 through 4, we can use the single equal sign to reassign them as 8 and 9. And then we can print nums. And now it's 0, 1, 8, 9, 4. We substituted 8 and 9 for 2 and 3 in place. If you tried that with a string, S3 is welcome. S3 2 to 4 is LC. If we tried S3, if we tried to change that LC to NC, we would get type error. String object does not support item assignment. So you can't change a string in place. You can change a list. You can update the contents of a list. So if one cell, if you have your list of 3 cells and one of the cell divides, you can change that. You can change what's there, or one of the cells dies, you can change what's there. You can't do that with a string. So that's what I was saying here. Strings are immutable. They cannot be modified. Lists are mutable. They can be modified. So we mentioned for loops before. For loops are really valuable for iterating over a set of values, but also valuable for iterating over a set of over a collection. So if we go back and look at our list 2, it has these 3 cells. For X in list 2, print X. Cell 1, cell 2, cell 3. So in this case, these are just strings. They don't have biological functions built in. But if these were objects in CompuCell contained in a list, we could say for X in list of cells, divide. So we could say each one of these cells should divide, or we could say each one of these cells should extend to Philopodia or whatever. So that's what loops allow us to do by iterating over any set of values, not just numbers. They can iterate over any collection. So one thing to notice is there's 2 ways of doing it. One is when you're iterating over the values for X in list 2, print X, cell 1, 2, 3. The other is for X in range len list 2, print list 2 X. So this does the same thing, but it does it based off of index position. It does it based off of the first item of the list, second item of the list, third item of the list. This format just executes the conditional block for whatever's in the list. So this is often whenever you can get away with it, this is going to be an easier, simpler solution with easier, simpler syntax. Just to be clear, these loops also work for strings. So we had above, we had our very long string S2. So when I say for X in, for W in, I just want to be clear that this variable is just a placeholder. It can be anything. So for W in S2, it's going to print all of each individual character of S2. Humpty Dumpty sat on a wall, blah, 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 blah. And just to be clear, you can also use conditionals in these loops. for X in, sorry, S2, print if X equals letter U, print X. Right? It's going to just print the U's. And we can change that to, or we can add something to do for the others. Not a U, not a U. So you can kind of mix and match some of the different concepts that we've demonstrated before, and you can start to imagine how once you're in CompuCell later in the week, you're going to have these collections of cells, and they're going to be objects that are stored in a list or stored in some other data structures that we'll get to. And then you'll be able to say, okay, for the ones that are epithelial, do this. For the ones that are mesenchymal, do this, or whatever your biological system has. All of these kind of basic tools in Python can kind of come together and create kind of a more sophisticated model that will behave in ways that replicate the biology you're interested in and help you answer questions about the biology you're interested in. And again, what we're emphasizing here is that the iterating through the collection is easier than using those index characters. So let's just run that code for the sake of it. So you have some letters that are in a string and letter. So it's got some letters with the lowercase and the capitals. And then we have a different string, which is word equals W exclamation point O parentheses, sorry, percentage R question mark D. For car in Word, so it's often, even though you can use anything here, it often makes sense to use something human interpretable. So in my case, I'm going to use for character for car in Word. Print if it's in this string, print print that it's a letter, else print car so W is not a letter because it didn't show up in here, even though that's, we know that it is, but it's not a letter because it's not part of this collection. Exclamation point is not a letter, 0 is not a letter, percent is not a letter, R is a letter because R shows up here in this. So let's change that to O actually. Okay. Run this again. Okay. So O and R were in this collection. So they printed is a letter and the other ones weren't. So they printed isn't a letter. One thing you should do, because in the interest of time, we're going to skip it, but you should be able to convert back and forth between using the index position and going plus equals 1 versus just stepping through the collection using a representative for loop. Here's another exercise. It's going to print the common letters in the string. So for character 1 in S1 and for character 2 in S2, if character 1 is equal to character 2, it's going to print it's a common letter. else it's going to print an uncommon letter. Now it's 2 for loops. That means it's going to test this first character T against every character in this. And then it's going to test the next character H for every character in this. So it's not just whether they're matching in sequence, because those 2 for loops are going to go through all the possible combinations. So let's just copy that in and to demonstrate what I'm talking about. So what happened there, it says end of line while scanning string literal in line 6, so line 1, 2, 3, 4, 5, 6. And you'll see a string started there, but because it copied from PowerPoint, it used a different type of character. So we actually need to end the string there. And this is often an issue when you're copying from PowerPoint. So now line 8 has an issue, and that's because invalid syntax. And what's showing up here is that this is not. Okay, it's not indented to the proper level. What else is going on? It says car1. So there's no connection between this string and the next variable. So what I needed to do was a plus there. Okay. So T and X are uncommon letters. T's are common letters. So it's running through every combination of letters from all of those. Is what I wanted to show. What happens when you use a nested for loop. So plus connects to objects in a print statement, or it connects to strings together, or it connects to lists together. It's just adding them together. So if we do list 1 plus list 2, it just connects them together like that. Whereas list 1 was just that, and list 2 was just that. And then for strings, it literally connects them. It connects strings together as well. Okay. I want to show what this loop does. Animals is a collection of cat, dog, and monkey. It's just strings in there. For animal in animals, and again, this could be anything. It could say for zebra in animals, for giraffe in animals, for X in animals, and then you print whatever variable that is, and it will print each one of these items. So once again, we have a syntax error in line 1. And it's once again an issue of copying and pasting from Excel. See, this character here doesn't match that one. So we just have to replace it. And now the code will work. Okay. Okay, so let's spend 10 minutes on this exercise. Okay, so the most basic way of doing this is again with for loops for Z in A, for W in B, and so Z and W are just random placeholders. Let me say that again. Z and W are arbitrary variables that will allow us to step through each one of these collections. If Z is equal to W with the double equal sign, let's print W. And then we don't want to do anything for the ones that aren't. And at the end, we'll print those were the common numbers. So 1, 2, 3, 5, 8, and 13. And the reason the 2 1 showed up is because 1 was in this list twice. And so it matched that list both times. The other alternative to doing this, the other alternative way of doing this is one we haven't really demonstrated yet. And that's to use a list to hold the values that we want. So we can create an empty list. And then we can borrow the same structure. Actually, we can say for Z in A, if Z in B, right? So for each one of these, if it's in there, we can do C.append, meaning add to the end of the list, Z. So that's simplest. And then we can print C at the end. And once again, so now we have a list, but we have 1, 1, 2, 3, 5. So how do we get rid of those double ones? One thing we can do is add a third condition. So after we've identified that Z is in both A and B, if Z is not already in the list of collected common numbers, then we'll append it. But if it is already in that list, we won't. So now we get 1, 2, 3, 5, 8, 13. And once again, if you didn't come up with any of those solutions independently, or you had mistakes in your solutions, don't worry about that necessarily. It's more programming at this level, model building is more about borrowing from stuff that you've seen work and mixing and matching it to get it to represent the models that you want. It's not a timed test. Okay, so we've talked about strings, we've talked about lists. Now let's talk about tuples. Tuples are like lists. Tuples are ordered sequences of elements that can mix element type. You can have number strings. You can have lists inside of tuples. You can have all kinds of objects inside of tuples. However, unlike lists, tuples are immutable and tuples are represented with parentheses. So let's run through some of these real quickly. TE equals open close parentheses. So if we check the type for TE, we can see that it's a tuple. TE can be 2, foo, 3. And then we can look at TE now, and it's those items. If we want to access individual items from those, we can use indexing just like before. That works just like with lists. And we can concatenate them. We can just add them together. And then we can slice tuples. TE 1 to 3 is foo3. We can do length on a tuple. However, if we try to change the elements of a tuple, TE, instead of TE1 equals foo, if we change it to panda, we'll get an error. Tuple object does not support item assignment. That's the same error we got when we tried that with lists. One thing I want to be clear about, TE started as an empty tuple, and then it became that tuple. Why was it allowed to do that? Doesn't that change? Doesn't that seem to contradict the idea of changing what a tuple is? And it doesn't, because what happened there. So, okay, let me try a different example. TE. Here is the tuple, right? Now, if I try to reassign the first indexed item from foo to panda using this, I get the error. But if I type in TE equals 2 panda 3, that works just fine. So why does this work, but this didn't work? And the idea is that this is reassigning the variable TE to a new tuple, to a new collection of data, whereas this is trying to change the existing tuple in position. So that's a key distinction that you're gonna have to keep track of going forward. So you can iterate over tuples in the same way that you could iterate over lists. So let's take a look at what that might look like. I'm going to create a tuple cleverly named, and I'm going to say 1 epi. And I'm going to say, it's going to be, the tuple is going to be made up of other tuples. 2 mes. 3 epi. And 4 mes. So there's alternating epithelial and mesenchymal data in this tuple. Let's just say that. Nums equals an empty tuple. Words equals an empty tuple. For t in a tuple, so we're going to step through these. For t in a tuple, I'm just going to print t and show you what that is. So what do you think is going to print out for t here? Just have a mental image of it. Is it going to be 1? Is it going to print out 1, then epi, then 2, then mes, then 3, then epi, then 4, then mes? Or is it going to print out this item, and then this item, and then this item, and then this item? And it's the latter, right? Because when you're iterating, when you're using a for loop through a collection, it's going to operate at the highest level of that collection, right? So a tuple is a tuple that consists of 4 tuples. So when you use a for loop on it, it's going to print out each individual tuple. Any questions about that? So there's a question. I was told at one point to close out if else statements before, as in assigning something to else, even if we meant for the else not to do anything. So I mean, I guess that's a matter of convention. I think in Python, it is not required to do that. You can do pass. I think that's probably the most elegant. So we had a, yeah, so these have not been closed out, right? So you could do else pass, I think is the sim is, and then else pass. But I think that's probably something that instructor showed you at one point to help you kind of think through the logic or use as a holdover. Sometimes we will put in an else pass here because I'm going to want to eventually do something else with the Z's that are repeated, but I'll do it later. So sometimes that's the only time I ever put in that pass as a reminder to myself that I want to make this more complicated later, but it's not necessary. And then the other thing that James is pointing out in the chat is one of the challenges in CompuCell is you're doing these incredible, you're trying to get this sophisticated models together, and the code gets really complicated. So adding extra complexity just makes it harder to read and harder to figure out where you're at. So I wouldn't necessarily recommend it. So, okay, I want to go back to this example I'm developing here. The first thing I wanted to point to make sure that everyone was clear on is when I print out, when I'm iterating through this for this tuple, it's printing out the highest level. It's printing out that level. It's not printing out the individual one in epi. If I want to access those, if I want to access one and epi, I have to do it through indexing. So let's say I want to, let's say I want to collect all the numbers in nums and all the words in words. The way I might do that is right, because the numbers are always the first item in this tuple, so I can always access it with T0. So that repeating structures, which you're going to have to get used to for accessing individual elements. Let's do that. And then if T, and then let's just say words equals words plus T1, comma. Let's see what this looks like. And then at the end, after the for loop, I'm going to go ahead and print nums, and I'm going to print words. So nums became 1, 2, 3, 4. Words became epimess, epimess. Now maybe I don't want to repeat this, so I could throw this into a conditional. If T index 1 not in words, then I'll add it. Otherwise, I'll ignore it. So that becomes really simple there. And then you can do different things. You can get the min of numbers, you get the maximum numbers, you can get the length of words, get the unique words. Yeah. So yeah, that's basically what this example is doing. And then you can set this variable up, right? You can set min n equals min, the minimum. It's a built-in function to find the smallest one in a tuple or list or a collection or any kind of collection really. Max n equals max nums, and then unique words equals the length of nums. And we can collect that data in in a new tuple if we want to. And then we can just examine new tuple. Yeah, 1, 4, 2. So as we've gone over already, lists are ordered sequences of information accessible by index. A list is denoted by square brackets. A list contains items or elements, and it can contain mixed types. It can contain numbers and it can contain floats and integers. It can contain strings. It can contain objects. List items can be changed, so a list is mutable. In contrast, so we've done indexing already. We've done changing elements, right? So we've done this. Here's another example. If L is equal to 213 and then we assign L1 to 5, then L is now 253. It's the same object. This can happen with a list. It can't happen with a tuple or a string. We can iterate over a list, just like we can iterate over a string. If you're going to use range, you have to know that it's exclusive. So you have to do a +1 if you want that to work, to contain everything over that list. But I want to get to this at the end here. So that was review, but this is important. This is new. So let's go ahead and create this list. L equals 2, 1, 3. So we mentioned briefly Python being an object-oriented language, but we didn't really emphasize what that means. So L is an object in Python. Sorry, if I type L, I'll see that it's a list. What that means is L has data or attributes. The attributes for L are 2, 1, 3. But it also has a built-in set of methods and functions. So L.append means that we're going to add to the end of L 5. And so it's connecting the data that we're working with the function that we want to use it. And that's what it means by object-oriented programming. Every collection of data has a set of functions associated with it. In CompuCell, you're going to build cells and other biological objects that will have a set of methods associated with them, such as divide or replicate or grow or whatever else. And you'll learn all of those details in the rest of the week, but this is how it works. It works by using this object-oriented nature of Python. So when I do L.append 5 and I look at L, I see it's been updated. And if I run it again, L.append, if I run that again, I'll see it's been added again. And what this does, by connecting the functions, the action with the data, it makes it so that there's less typos, there's less issues, there's less risk of contamination and things like that. So we've talked about using concatenation to connect lists. We've talked about using the plus sign. And we've talked about using those to generate new lists. You can also extend. You can mutate a list with extend. So L.extend, let's say list 1. Let's remind ourselves what list 1 was. List 1 was 1, 2, 3. So if I do L.extend list 1, and I look at L now, it's 2, 1, 3, 5, 5, 1, 2, 3. So that's another tool in our kit for adding to this list. You can delete, there's other things we can do. We can delete elements at a specific index. So if I don't want this duplicated 5, I can just delete it because it's 0, 1, 2, 3, 0, 1, 2, 3. The third indexed item is 5. And I can check that. L3 is 5. So if I want to delete it, I can del L3, oops. And now when I check L, it doesn't have the duplication anymore. The other thing you can do, and this is really useful when you're working through large collections that you want to do things to, is pop, L.pop. So what L.pop did was return the last item. Notice when we did a lot of these functions, extend, it doesn't return anything. It doesn't print anything out. It doesn't show us anything. It just makes the change. In this case, it returned something, which we will talk about when we do functions. It returned something, it provided 3 to the screen, and it made a change underneath. So now so what happened is that last 3, it got popped off and returned to the user, and then the list, the underlying object, had that thing removed. So if you had a collection of cells and you wanted to do something with each of them, you could then use pop to remove one cell at a time from your list and then have it undergo some process. If you didn't need to keep that collection in mind anymore. So that's what's useful there. It returns the last item in the list and it mutates the list to not have that item anymore. You can convert lists to strings and back. This is useful to know, but so take a look at S. S was that. I can do list S and it'll convert it that way. And then I can do so that's not defined because it's supposed to be str. So now this whole thing is inside of a string, right? If I want to join the characters join a list of characters in a string, I have to use .join L. So let's go through some of these. S equals I greater than 3 CS. I love CS. List S breaks those up into individual characters. S.split, but S itself hasn't changed. List S breaks those into individual characters, but S itself is still a string. So if you want to work with list S, you have to create a variable to hold it. So now I have S and I have list S. And those are 2 separate things. The other thing I can do is S.split, and I can split based on any character. In this case, let me split it before and after that greater than sign, and it broke it up into a list with I and 3CS. Often you'll use a split on a space to break it up into different words or something like that. But anyway, if I take an empty string and I do join list S, so join that list to it, it will add those characters back into the list. If I do an underscore dot join list S, it does this. So how do you reconcile that? Basically what's happening is you have a string and you're going to join all the elements of the list that you feed in separated by whatever's in that string. So since that string was empty, it's going to connect all of the elements of list S without any separations. Since this string consists of an underscore, it's going to join all of the elements of list S separated out by an underscore. sort and reverse are important. So if we look at L, we can do L dot sort. Oops. So nothing was returned to the screen here. How do we know something happened? If we look at L now, we can see that it's been sorted from lowest to greatest. So that's called mutating, again, when nothing gets returned, but the underlying object changes. And then if I do L dot reverse, the same thing happens. Nothing happens there, but the underlying object got changed. So you have to be careful when you're using those operations, because these changes aren't always visible and aren't always immediately noticeable. And so these can create things called side effects where some of these things interact with each other in ways that you don't expect. The best way around that is by using something called an alias. Well, so another way that can happen actually is by using something called an alias, is through something called an alias. So if we do A equals 1, this is a little bit of a tricky concept, but once you get it, it'll be fine. If we do A equals 1 and B equals A, then if I print A and I print B, I think no one will be surprised that they're both 1s, right? And then if I update, and now I say A is 2, and now if I print A comma B, I get 2, 1. No one should be surprised about that, because A got changed and B didn't. Okay, but now if I do warm equals red, yellow, orange, and I do hot equals warm, and if I print the two of them together, print warm, print and hot, they're both the same, right? Now, if I do hot dot append pink, and now I repeat my print warm and hot, you might be surprised to know that they're both have been changed. Even though I only appended pink to hot, warm got changed as well. So this is called a side effect. What is happening here is that both warm and hot are pointing to the same underlying object. And so when you're working with a mutable data structure, such as a list, you have to watch out for changes happening in one part of your simulation that might affect other parts of your simulation without you realizing it. When you're working with immutable collections, such as strings, integers, and tuples, you don't have to worry about that. So that dictates which ones you use. The ways around that is to create a new list and copy every element. So instead of saying hot equals warm, I should have said hot equals warm colon. And then when I made these changes, when I changed hot, warm wouldn't have gotten changed, because this basically says hot is going to be a copy of warm, but not the actual same object underneath. So that's something to keep in mind. So let's look at this example. So we've got warm. And then if we do sorted warm equals warm dot sort, print warm, print sorted warm. This is also a source of unexpected error, right? Because warm is red, yellow, orange. Warm.sort will change warm to be orange, red, yellow, and that's just alphabetical order. But I thought it's possible I could have thought that I was making a copy of warm using sorted of the sorted list using sorted warm. But if you'll remember, when you run warm.sort, nothing gets returned. See, nothing got returned. Therefore, nothing got assigned to sorted warm because nothing got returned from this. And that's why when you print sorted warm, you get none. The way around this is, once again, none type is not subscriptable. Okay, actually, yeah, the way around it is you have to do this after you do the sort. You have to assign sorted warm equals warm after you've done the sort, and you can use the colon to make sure it's a copy. So let's just again, and you'll get none type again. Anyway, that is what you have to watch out for with lists in particular. We've mentioned before, lists can be nested, meaning lists can have lists inside of them. And this can make it especially complicated when you're trying to figure out these side effects. Avoid mutating a list as you're iterating for this purpose, because if you start changing a list inside of another list, you may not be able to keep track of what you are doing to the list. So don't do L1.remove E or L1.pop E when inside of a loop. Instead, make a copy and work your way through the copy.